All right. As a math coach, one of the things I hear the most from teachers is, what do I do with my students who don't know their times tables, their multiplication facts? And I hear this from third grade teachers, fourth grade teachers, fifth grade teachers, all the way up to whatever grade level I work with. It just seems like this is a problem that we recognize in third grade, but man, we're never able to solve it in fourth, fifth, sixth grade. So we're not going to blame the third grade teachers at all. We're just going to say, hey, what's going on with the system that is preventing kids from finally learning their multiplication facts? There's lots of advice out there, lots of books you can buy. I'm going to give you an idea based on what I read from a particular article from NCTM. And I want us to think about this idea of, let's say 4 times 6, just as a quickie. Then I'm going to get to the magic order of how we should teach things, all right? So let's start with 4 times 6. So 4 times 6, there's a lot of ways we can get it. One way to do it is we could say, well, let's imagine 6 buckets, and inside each bucket are 4 apples. And then, all right, so as we've got our little apples, now we can just count them. We could say, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right. And now we know that the answer is 24, but we did that through a system of counting. Now that's fine if that was all that the student had at their disposal, but we need to get to a more sophisticated approach. And the next sophisticated approach is using additive thinking rather than counting. What might that look like? That might look like skip counting. 4, 8, 12, 16, 20, 24. So the students are really just kind of using this add-on method. Add 4 more, add 4 more, add 4 more. And heck, they might even do, 6 plus 6 plus 6 plus 6 and write that down and recognize that 6 plus 6 is 12. Another 6 plus 6 is 12. And now 12 plus 12 is 24. Both of these work, but they're really grounded in that idea of additive thinking. So what we're going to really focus on in this video is, how do we get students thinking multiplicatively to get that answer, where they're really operating on larger chunks of numbers than just 4, 4, 4, 4, or repeatedly adding 6. We want to start chunking these numbers together, all right? And it's not really just about the facts, folks. It's not like, well, first we're going to teach the 1s, then the 2s, then the 5s, although there is some of that. There are some foundational facts that we really want to get taken care of early on, because then we're going to use those facts to attack the multiplication with more sophisticated approach. For example, we might start with our 2s, 5s, 10s, 0s, 1s, and squares. Those are our foundational facts that everything else is going to be derived from. And then we're going to use these foundational facts to employ some smart multiplicative strategies instead of always being stuck on adding or counting strategies. For example, we're going to use a known fact and then add one or subtract one group from it. For example, if I don't know 9 times 6, but I know 10 times 6, well, then I'll do 10 times 6 and subtract one group of 6 because I have too many 6s. I only want 9 6s. 10 6s is 60. Take away a 6 gives me 54. Or I might do some doubling and halving, where if I recognize that one or more of the numbers being multiplied are even, I might take advantage of this doubling and halving effect. For example, 6 times 8, I might think of this as, well, I don't know 6 times 8, but let me cut that in half and do 3 times 8. So there's my 24, and then just double it because I need 6 8s, not just 3 8s. So 6 times 8 is 24. 3 times 8 is 24, and then add another 24 gives me 48. All right. Or I might use a square number as my launching pad. For example, 7 times 7 is 49. We want the kids to know that 7 times 7 is 49, but if I want 7 times 8, I might add an additional 7 because I have 7 times 7, so I have 7 7s, and I need 8 7s, so I might add on an additional 8. In my example on the screen, if I don't know 7 times 6, but I know 6 times 6 is 36, I'm just going to add one more 6 to it to get to my 42. And then the last one is decomposing one of those factors into some convenient numbers. For example, if I don't know 8 times 7, I might take that 7 and decompose it to 5 and 2. And now I'm going to multiply 8 times 5 is 40, and 8 times 2 is 16, and add those together to get 56. So really, folks, we're going to be focusing on these derived strategies as the biggest part of our work. All right? And so there is still some sense of the order that we might do our facts in. So first thing we're going to do is we're going to take care of our foundational facts. We're going to take care of our 1s, our 2s, our 5s, and our 10s. All right, so these all become our foundational facts. And look at that. Out of 12 times 12, which is 144 facts, we've just narrowed it down significantly with our 1s, 2s, 5s, and 10s. Well, if we know our 2s, then we can immediately know our 4s by doubling and halving. And what might that look like? Well, that might look like if I don't immediately know what 4 times 7 is. Well, I know 2 times 7 is 14 because that's fair game. That's fair game because it's already one of our known facts, our prior known facts. And then all I have to do is just add another 14 and I get 28. And what does that look like pictorially? That might look like I've got 4 copies of 7, except you can't see that because I wrote it in a funky spot. So let me move that over. And what does that look like? It looks like 4 copies of 7, but 2 copies of 7, these 2 copies of 7 is 14, which means these 2 copies of 7 are 14. So 7 times 2 is 14, times that by 2 gives us 28. All right, so if we know our 2s, then we immediately know our 4s, because all we have to do is get our 2 fact and then double it to get our 4 fact. And once we've taken care of our 4s, then we're going to think about our squares. Now, those squares become a launching pad for a lot of facts. What are the facts that we need to worry about? We need to worry about 3 times 3. At this point, we need to know 6 times 6 because right there is 6 times 6. And then we need to worry about 7 times 7, 8 times 8, 9 times 9. So these are facts that we might need to do some memorizing, but we're not going to memorize because we're going to build on prior knowledge. For example, if I need to know 6 times 6, what am I going to do? Well, 6 times 6, 6 times 6, I might say to myself, well, I know that, 3 times 6 is 18, and so another 3 times 6 is 18, so I'm going to add those together to get 36. So I'm using a doubling and halving strategy right there. Or I might use the idea of I know my 5 times 6 is 30. So I just need one more 6. That's going to give me 36. So we're using one of those foundational facts, the fives fact, to get that answer. For example, if I need to know 7 times 7, what might I do? Well, I know that my 5 times 7, because that's one of my foundational facts, is 35. I need 2 more 7s to get my 7 sevens. And so 2 7s is 14, and I'm going to add those together and get 49. So this is what we mean by using multiplicative thinking instead of like constantly using skip counting or repeated addition or all that sort of stuff. We're really chunking our numbers together. All right, so I'm going to go back to the browser. And when we think about this, so now we've got our 4s. So what do we have so far? We have our 1s, our 2s, our 5s, our 10s, our 4s, because that's just doubling. And now we know our squares, all right? And our squares we're going to use that 5 fact as our launching pad for a lot of that. And then what are we going to do? Well, we're going to take advantage of the fact that multiplication facts are commutative. If I know 6 times 4, let's see, 6 times 8, then I also know 8 times 6. It's symmetrical. Or if I know 6 times 7, I know 7 times 6. So really, we don't have all of these facts that we need to memorize or learn. We only have half of them because of that symmetry. All right, so now what are we going to do? Well, if we look at it, we've got a big column of our 3s, our big column of 6s, 7s, 8s, 9s, and 11s. So let's take care of our 11s. 11s are super easy. 11s, all we have to do is a row of 11s is recognize that it's 10 of them plus one more copy. So how would we attack that for like 3 times 11? We would recognize that 3 times 11 is 3 times 10, which is 30 plus 3 more, and we get 33. Or how would we do 8 times 11? Well, we would recognize that 8 times 11 is really 8 times 10, which is 80, plus one more copy of the 8. It gives us 88. Of course, students are going to start to recognize that classic, doubling, like 3 times 11 is 33. 4 times 11 is 44. 5 times 11 is 55. So it's that same digit shows up twice, kind of mnemonic. Is that what the kids are going to come up with? But it's not just a stupid mnemonic. It's really coming from the fact that they know that, let's go back to the browser, that 7 times 11 is really 10 copies of 7, which is 70, plus one more copy of 7, which gives us 7, and so our total is 77. All right, so that's where we're at for our 7 times or our 11s. All right, I'm going to go back to the browser and say, well, now that we know our 11s, man, we started with 144 facts, and now we're down to just these last few standing here. And so what are we going to do? We're going to attack those 3s. And we've got 3 times 6, 3 times 7, 3 times 8, 3 times 9, and 3 times 12. So these are the facts that we need to figure out. But we're not going to do it just by memorizing the facts. We're going to use those strategies that I mentioned in the earlier slide. So what is that going to look like? I don't know. Let's say we've got 3 times 6. We've got 3 times 7. We've got 3 times 8. Let's just start right there. So what is 3 times 6 going to look like? Well, I might say, I know that 3 times 6 is 3 times 5 plus an extra 3, because I only have 5 3s, but I need 6 3s. Oh, so 3 times 5 is 15 plus an extra 3 is 18. So there I go. I'm learning my threes now. I'm finally getting to my threes. What might I do for 3 times 7? 3 times 7, I might say, oh, well, that's 3 times 5 plus an extra 2 more threes. So we've got 3 5 times, and then we have another 3 2 times. And so that gives us 15 times 6. And all of these are building from prior knowledge, our foundational facts, the 1s, 2s, 5s, and 10s. They're so important. And so now we got 21. Now, yes, of course, kids could have just skip counted 7, 14, 21, but that's going to keep them in the addition land, and we need to nudge them towards multiplicative thinking. That's the whole point of this video. And you got it. What would 3 times 8 look like? I don't know. It probably looks like 3 times 5 plus a 3 times 3. So we've got 15 plus 9. Now the kids might use their fingers, but we're going to get 24. But we could also use the doubling and halving. We could double that to be 6, cut this in half to get it 4. 6 times 4 is a fact they might know. They might not know 3 times 8, but 6 times 4 they might, and they, of course, are going to get 24. That's a derived fact from an earlier example. All right, so all of a sudden, going back to my browser, we now have all of our threes taken care of. So we've taken care of our 1s, then our 2s, then our 5s, and then our 10s, and we're using those strategies. Right here, we're using all of these derived strategies to make sense of our foundational facts for the 1s, 2s, 5s, and 10s. And then we're going to take care of the 4s, because if you know your 2s, you know your 4s. You just have to double it. And then we're going to take care of our squares. And then we're going to take care of the fact that this is symmetrical, so we only have to worry about half of them. And then we're going to take care of the 11s, because the 11s are pretty easy. It's just times by 10 plus an extra 1. And then we're going to take care of our 3s using the derived facts. So really, we're down to these final 11 facts. These are the final 11 facts that are kind of the last men standing that we need to really worry about. So these are the ones that we're going to focus on using our derived facts. So let's see. I can see that we've got 6 times 7. So what might we do using our prior knowledge? So if we know we need 6 times 7, what might we do? Well, we might say, I know that 7 is really 5 and 2. So I might say, oh, okay, I need 6 times 5, which is 30, and 6 times 2, which is 12, and now I'm going to add those together to get 42. And if you're not sure what the heck that picture would look like, that picture would look like 7 6s. 6, 6, 6, 6, 6, 6, 6. And we're really saying, okay, these 5 6s right here is 30. These 2 6s right here is 12, and we're going to add them together. So as you're learning your multiplication facts, of course you're going to use some addition, but we're not relying on that constant skip counting of 6, 12, 18, 24, etc. We're chunking them together into larger pieces, and then we might be adding or subtracting them. All right, and then so now we're at 6 times 7. We have 6 times 7. So now, right there, 6 times 7. And then now what would we do for 6 times 8? Well, 6 times 8 is kind of a nice one. 6 times 8, we might say, all right, well, 6 times 8, we could take advantage of doubling and halving, because I recognize that both of these factors are even. So I might turn this to a 3 and this into a 16. Or if I don't like that, and that doesn't really help me a lot, I could take that 6 and 8, and I might double the 6 and cut in half the 8. And maybe that doesn't help me, but I can cut the 4 in half again and double the 12 again. And now 12 times 24, 2 times 24 kind of speaks to me in a better way. So I might use doubling and halving for 6 times 8. But 6 times 8, I also might say to myself, I don't know 8 sixes, but I know 5 sixes is 30. And 3 sixes is 18, so I'm going to add those together to get 48. So again, I'm going to be using these derived facts. So what are we going to do with the kids? So at this point, we have just 11 facts that we need to really focus on. So what I'm going to do is I'm going to put up a fact on the board. Let's call it 6 times 8. That's one of the last men standing. So 6 times 8 is right here. And so I'm going to do a number talk on 6 times 8. And I'm going to say, what are all the different ways we could get 6 times 8? And then I'm going to highlight the multiplicative ones, because of course some kids are going to use counting. Some kids are going to use additive thinking. But I'm going to highlight the multiplicative thinking. And I'm going to say, all right, students, I'm going to give a 3x5 card to everybody. And I'm going to say, on the front of the card, write 6 times 8. On the back of the card, I want you to choose one of these multiplicative thinkings and copy it onto the back of your card. And they'll draw whatever it is they want to draw, whether they draw this kind of decomposing, or if they use doubling and halving, whatever their multiplicative thinking is, they're going to draw that on the back of their flashcard. And if they want, they can kind of draw even a tape diagram, 6, 6, 6, 6, 6, 6, 6, 6. And actually, this is actually a nice one, because I see 6 times 4 is 24, and another 6 times 4 is 24. Put them together, that's 48. So they're going to draw one of these multiplicative thinkings on the back of their flashcard, along with the correct answer of 48. So really, students don't need a bunch of flashcards. Really, it gets down to these learning your foundational facts, your 1s, 2s, 5s, and 10s. And then once you know your 2s, you know your 4s. So we might create some flashcards there. And once you know all that, you're going to learn your square numbers. So we might have to kind of learn that and practice those with our flashcards. But ultimately, the only flashcards you're really going to need to really focus on is these remaining 6s right here, your remaining 7s, 8s, 9s, and that last one right there, 12 times 11. So these 11 facts are the last cards standing. So there you go. This is just my idea of how we might help our students kind of master those multiplication facts. The idea is to get them away from, let me scroll up. Look at all this work that I did. We're going to get away from strategies that are based on addition or counting. We're going to move them into that multiplicative thinking, where they are thinking about chunks of numbers and adding them together, all right? And then we might do that work in a particular order, all right? So we might start with our foundational facts, 1s, 2s, 5s, 10s. Our 4s are doubled the 2s. We're going to do our squares. We're going to take advantage of the fact that we've got symmetry. And then we're going to take care of our 11s, because our 11s are super kind of easy. And we're going to take care of our 3s. That's right here, the 3s is where we're going to do a lot of work. And we might make some flashcards, but really we're going to work on those derived facts. How do we know that 3 times 8 is 24? Or how do we get 3 times 8 is 24 without skip counting? How do we chunk those numbers together and add them in parts, like, partial products? And then once we've got the 3's, we are now down to the 11 facts that are hard to learn, but they're not hard to learn. We're just going to use multiplicative reasoning, and we're going to write the fact on the front. We're going to write the multiplicative help on the back along with the answer. We're not just going to put the answer. We're going to write down that multiplicative thinking that is getting to helping us get that fact. And that wraps up this video. It's just my way of thinking, and I would love to hear your thoughts on this in the comment section. Thank you.